NPK hun. Today we are running through nitrogen, phosphorus and potassium and the role that they have in fertilizers. This builds on from a previous episode on fertilizers, so make sure you check that out to get up to speed. And without further ado, let's dive in. So, nitrogen containing compounds in fertilizers. The nitrogen containing compounds that are found in fertilizers are made using ammonia and nitric acid. And this is manufactured by oxidizing ammonia. So that reaction is ammonia plus nitric acid goes to ammonium nitrate. And if we want the symbols, that's NH3 plus HNO3 goes to NH4, NO3, and that's all aqueous. Now, because it contains nitrogen from two sources, ammonium nitrate is exceptionally rich in nitrogen, so it's ideal for use in fertilizers, okay? So ammonium nitrate, exceptionally rich, stunning. So ammonia, do you remember where we get that from? We get that from the Haber process, which is covered in some other episodes, so make sure you check that out. And nitric acid we get from oxidizing ammonia, and then ammonium nitrate, boom, we combine those two sources. Now, phosphorus, don't think I forgot about you. We're going to be talking about where that P comes from. Phosphate rock is the source of insoluble phosphorus that is obtained by mining. Useful soluble product can be attained by treating the rock with different acids. So we treat phosphate rock with phosphoric acid and calcium nitrate. And treatment with sulfuric acid will yield a single superphosphate, which is a mixture of calcium sulfate and calcium phosphate. Just going to run through that again. So if we want to get phosphoric acid and calcium nitrate, we use nitric acid. So nitric acid gives us phosphoric acid and calcium nitrate. Whereas if we use sulfuric acid, we get a single superphosphate, okay? So sulfuric acid, superphosphate, nice, they both start with S. Nitric acid gives us phosphoric acid and calcium nitrate. So we can put that together into a cute little equation. Phosphate rock plus nitric acid goes to phosphoric acid plus calcium nitrate, okay? So what is the source of insoluble phosphorus? That is our phosphate rock. Okay, and lastly, we're going to be talking about potassium-containing compounds in fertilizers, and there are two main soluble sources of potassium that can be used as fertilizers in their raw form. Both of these soluble sources are extracted using mining. So we've got potassium sulfate and potassium chloride. Both of those we can get from a cute little bit of mining. So let's run through phosphate rock again, and we can get different products from phosphate rock by reacting it with different acids. So do you remember what we get if we use nitric acid? With nitric acid, we get phosphoric acid and calcium nitrate. Sulfuric acid, remember, sulfuric acid gives us the superphosphate. And if we want to take it a step even further, we can treat it with phosphoric acid, and that gives us triple superphosphate. Isn't that fun? So the useful soluble product of treatment with phosphoric acid is superphosphate. So, because think about it, it's like we're adding phosphoric acid to a phosphate rock. So we get triple superphosphate. Stunning. Okay, so let's have a quick round of quizzing before we finish. Where do we get potassium chloride and potassium sulfate from? We get those from mining. Are they soluble or insoluble? They are soluble. Okay, what about that nitrogen we started with? Where does that come from? So we react nitric acid and ammonia together to form ammonium nitrate. So that's where that nitrogen comes from. Okay, that brings us to the end of this episode. I hope everything made sense and everything was clear. Have a listen again, have a little read online, do what you gotta do to feel up to speed. Thanks for joining, and I'll catch you on the next episode.